Have you ever wondered what it would be like to travel back in time and witness historical events or change past decisions? Time travel, a concept that has fired the human imagination for centuries, is a recurrent theme in countless science fiction tales. It has become an integral part of our pop culture, with films, novels, and TV shows offering us a glimpse into the fascinating possibilities of journeying through time. The concept of time travel often sparks a myriad of questions in our minds. What if we could change the past or foresee the future? What would be the implications of such actions? These are intriguing questions, and the answers are even more captivating. This brings us to the concept of the time paradox, a concept that adds an exciting twist to the idea of time travel. A time paradox is a theoretical scenario that occurs when a time traveler causes a change in the past that would prevent their future self from ever going back in time in the first place. It's a contradiction that challenges our understanding of time and causality. Imagine, if you will, a situation where you travel back in time and change something that would prevent your birth. If you were never born, then you could never have traveled back in time. But if you didn't travel back, then you wouldn't have changed anything, and thus you would be born. This loop of events is what we call a time paradox. The time paradox creates a conundrum that seems impossible to resolve. It questions our understanding of cause and effect, challenging our perception of reality. It's like a riddle wrapped in a mystery inside an enigma, a puzzle that has baffled even the brightest minds. So, here's a thought to ponder. If time travel were possible, wouldn't we already have visitors from the future? Time, as we perceive it, is a dimension that we're constantly moving forward in, but can we reverse this journey? Imagine time as another dimension, akin to the three dimensions of space we're familiar with: length, width, and height. So, just as we can move freely within these three dimensions, the question arises, why not the same for time? To grasp this, let's dive into Einstein's theory of relativity. This revolutionary theory suggests that space and time are interwoven into a single continuum known as space-time. Objects, including you and me, warp this space-time fabric, creating what we experience as gravity. The more massive an object, the greater its gravity and the more it warps space-time. Now here's where it gets interesting. Einstein's equations suggest that under extreme conditions, it might be possible to twist and manipulate this space-time fabric to create shortcuts known as wormholes. A wormhole, in essence, is a tunnel through space-time, potentially connecting two distant points with a path that's significantly shorter than the usual route. Sounds like an express ticket to the past, doesn't it? Well, not quite. While the theory is fascinating, creating a wormhole and keeping it stable requires an enormous amount of energy and exotic matter, which is currently beyond our technological capabilities. Even if we could create a wormhole, it would be microscopic and short-lived, making it impossible for us to travel through. Moreover, there's another catch. Even if we could travel back in time, any change we make there could potentially create paradoxes that would alter the course of history, leading to what's known as the grandfather paradox. This is a hypothetical situation where a time traveler goes back in time and kills their own grandfather, preventing the time traveler's existence. While the physics might suggest time travel is possible, the practicality of it is a whole different story. So, while we can dream about time machines and adventures in the past, the laws of physics keep our feet firmly anchored in the present. Even if we could technically travel through time, could our bodies handle the journey? A question that nudges us to delve into the biological implications of time travel, something that science fiction often neglects. Let's start with aging. If we could zip to and fro through time, how would this affect our body's natural aging process? Would we age slower or faster? Some theories suggest that time travelers might age faster or slower than those who remain stationary. This is due to the hypothetical influence of time dilation, a concept derived from Einstein's theory of relativity. The faster you move, the more time slows down for you compared to someone who is stationary. So, hypothetically, if you were to travel at near light speeds in a spaceship and return to Earth, you might find everyone else has aged more than you. In simple terms, you'd be younger than your chronological age. Another crucial aspect to consider is our internal body clock, or the circadian rhythm. Our bodies run on a roughly 24-hour cycle, responding to light and darkness in our environment. It's what makes us feel alert during the day and sleepy at night. Now imagine the chaos if we were to suddenly shift years into the past or future. The disruption could be akin to the worst case of jet lag you've ever experienced, or even worse. Our bodies would struggle to adjust to the new timeline, potentially leading to severe health issues. Not to mention the immune system. If we traveled back in time, we'd be exposed to pathogens that our bodies have never encountered. Similarly, the future could hold diseases for which we have no immunity. The risk of carrying or contracting diseases across timelines could have catastrophic implications. In conclusion, our bodies are fine-tuned for life in the present. They follow a rhythm, a cycle that's synchronized with the world as we know it. Time travel, as fascinating as it sounds, could disrupt this harmony and wreak havoc on our biological systems. The human body is designed to live in the present, not the past or future. If you could go back in time, what would you change? And what might be the consequences? This question brings us to the ethical dilemmas that time travel presents. A journey to the past might seem like the perfect chance to right wrongs and prevent disasters. Imagine being able to stop the sinking of the Titanic, or even the occurrence of more devastating events like wars. The potential to save lives and avoid suffering is a compelling argument for the benefits of time travel. However, it's crucial to remember that every action has a reaction, often with unintended consequences. What if preventing a shipwreck leads to an even greater disaster? What if stopping a war only delays it, resulting in even more destruction later on? The potential for good is significant, but so too is the potential for harm. Furthermore, there's the temptation to use time travel for personal gain. What's to stop someone from going back in time to amass a fortune, create a powerful dynasty, or even change the course of history to suit their desires? This power could easily be abused, leading to a future dominated by those who control the past. But let's suppose for a moment that we could ensure time travel would only be used for good. Even then, the question remains, should we alter the past at all? After all, our history, with all its triumphs and tragedies, has shaped our present. It's made us who we are, individually and collectively. To change it might be to erase ourselves. And then there's the granddaddy of all time travel conundrums, the potential to create alternate timelines or realities. Change one thing in the past and you could set off a chain reaction that leads to a completely different present. You might return to a world unrecognizable, where you don't exist, or where things are worse than they were before. The past is a tapestry of events that have shaped the present, and altering it could have unforeseen consequences. Time travel, then, is not just a question of physics or biology, but of ethics too. It's a tantalizing prospect, but one that comes with a heavy burden of responsibility. So, is time travel to the past truly impossible? An intriguing question indeed, and one we've been delving into throughout our journey today. Let's take a moment to revisit the main points we've covered. We first grappled with the paradox of time travel, a conundrum that leaves us pondering the inexplicable complexities of altering past events. Imagine, if you will, going back in time and changing something that would then prevent your own birth. This paradox leaves us in a loop of infinite regress, a cycle that seemingly has no resolution. Next, we delved into the physics of time travel. The laws of physics as we currently understand them suggest that the energy required to create a wormhole or some other form of time portal would be astronomical, far beyond our current capabilities. Not to mention the fact that such a portal might collapse in on itself the moment it is created, posing additional challenges. Then, we explored the biological implications. The human body is a product of its time, adapted to the specific conditions present at the moment of its existence. Traveling back in time could expose us to pathogens our bodies have no defense against, or conversely, we might bring back modern diseases that could wreak havoc on past populations. Lastly, we considered the ethical dilemmas. The potential to alter history, to change the course of events on a global scale, carries with it immense responsibility. Who would decide what changes to make, and how would those decisions be governed? The ethical implications are vast and complex. While time travel is a captivating concept and a recurring theme in science fiction, our current understanding of physics, biology, and ethics suggests that it's not feasible. However, this doesn't mean we stop exploring or questioning. After all, what we know about our universe is constantly evolving. For now, time travel remains a concept of fiction and speculation, a tantalizing idea that challenges our understanding of the universe and our place in it.